Hello everyone. Let's get straight into the 1.3 test review. Now, before we actually get into the questions, I just want to preface this by saying that Unit 1.3 is in fact all about lines and angles. So in order to be proficient in this test, you're going to need to know a couple of things. The first thing is your angle relationships. These are relationships like complementary angles, supplementary angles, and vertical angles, which show up in nearly every other unit when we're talking about angles. You also need to know your transversal relationships like your alternate interior, alternate exterior, consecutive interior, consecutive exterior, and corresponding angles. Last but not least, you should know how to read and complete two-column proofs using all of the vocab that we've learned, and in addition, the 4 important properties like the reflexive, transitive, symmetric, and substitution properties. If you have any questions or concerns, all of this information can be found in the lines and angles packet that we've already completed in class. So with that being said, let's get right into the review. Now, question number 1 of this test review asked to determine the appropriate justification for each of the following statements. Basically, we're going to determine if the two angles that were given are sufficient to show that these two lines, MN and PQ in our diagram, are parallel, and we're going to determine what type of relationship those two angles have to each other. So let's first look at part A. In part A, they ask us to find PTS and NST. Now, PTS is going to be this angle that we see right here on our diagram, and NST is this angle. If we look carefully at these two, we'll notice that these are alternate interior angles. So in this blank, we're going to fill in with the fact that alternate interior angles are congruent. And if you think about it carefully, two angles can only be interior if they're in between two parallel lines. So this information is sufficient to show that these two lines are parallel. Now let's move on to part B. For part B, we're going to look for angles NST and QTS. NST, once again, is this angle right here in the corner, and QTS is going to be this angle right here. So these two, as we can tell, are going to be our same side interior angles. So we're going to fill in this blank by saying same side interior angles are supplementary. And like I said in the previous problem, since these are two interior angles, that means they have to be in between a set of parallel lines. Therefore, these two angles are sufficient to show that they're parallel. Now, let's move on to part C. For part C, we're looking for angles RSM and UTP. RSM is going to be this angle at the top, and UTP is going to be this angle at the bottom. Looking carefully, we'll notice that these are two same side exterior angles. So we're going to fill in the blank by saying same side exterior angles are supplementary. Now, this is where things differ. You'll notice that these are exterior angles. In the two previous problems, we had a set of interior angles. So these two angles are actually not sufficient enough for us to determine that these two lines are parallel. So again, we should say that these two angles are not sufficient. This brings us to part D. In part D, we're looking for RSN and STQ. RSN is this angle in the corner here, and STQ is this angle here as well. Looking carefully, once again, we'll notice that these two angles are actually a set of corresponding angles. So in this blank, we're writing that corresponding angles are congruent. And in fact, since one of our angles is actually an interior angle, then we can say confidently that this is sufficient to say that our two lines are parallel to each other. And that is it for problem number 1. Let's move on to problem number 2 now. All right, for question number 2, you'll notice that they give us 4 angles. They give us angles ABC, DEF, JKL, and MON. In our question, they also give us a bit of information. They tell us that ABC is complementary to JKL. We know that MON is supplementary to DEF. And we also know that MON is complementary to ABC. To be successful with this question, we have to know what the words complementary and supplementary mean. Now, we learned that complementary angles are two angles that add up to 90 degrees, and supplementary angles are two angles that add up to 180 degrees. Now that we know this information, we're actually going to mark that on our diagram as well. We know that these two angles add up to 90 degrees. We also know that these two angles add up to 180 degrees. And finally, these two angles again add to 90 degrees. What we want to do before we even look at the statements that were given is see if we can kind of deduce some information on our own. And to do that, we're going to need those 3 algebraic expressions that they give us for angles DEF, JKL, and ABC. Since we know that angles ABC and JKL are complementary, we can set up an equation to say that the part plus the part equals the whole. In this case, ABC has the equation 7x plus 17. So we're going to write 7x plus 17. We're going to add that to the equation for JKL, which is 3x plus 23. And we're going to set that equal to 90 degrees since both of them are complementary angles. If we go through our answer choices carefully, you'll actually notice that there's one option that matches this equation closely. So the second statement that we see is a true statement because of the fact that this is given. Again, since they give us the information that ABC is complementary to JKL, we know that this equation has to be true as well. Now, since ABC plus JKL is 90, and we know that angle MON plus angle ABC is also equal to 90, then we can assume that JKL is equal to MON. So let's write that out down here. Again, if ABC plus JKL is 90 degrees, and we also know that ABC plus MON is also 90 degrees, then we can assume that JKL is equal to MON by the transitive property. What this means is that the first statement we're given is also true. Let's see if we can find another one of these statements that is also true. Since we just found out that JKL is equal to MON, and from what we're given in our question, we know that MON and DEF have to equal 180, then we can also assume that JKL plus DEF also equals 180 by substitution. This makes the fourth option a correct answer as well. So, once again, we know that the first option is true by the transitive property. We know that the second option is true because of the information that we're given. And we know that our fourth option is true by substitution. And that is it for question number 2. Let's move on now to question number 3. For question number 3, we're finding the measure of 4 angles. We're finding the measure of angles KZH, the measure of DRK, the measure of KRH, and the measure of angle XHT. In order for us to do that, we're actually going to use the vocabulary that we've learned in regards to transversals. So let's first start with part A, and let's find the measure of KZH. Angle KZH is this angle right here. If we look closely at this angle, and we look closely at the angle that we're given, you'll notice that these two angles are alternate interior angles. We know in this class that alternate interior angles are congruent. Congruent means that these two angles are the same exact measure. So if this angle is 66, then KZH also has to be 66 degrees. Now let's move on to part B. Let's find DRK. DRK is going to be this angle right here. If we compare it to this other angle that we're given, that's 78 degrees, you'll notice that these two angles are corresponding. Corresponding angles are also congruent. Therefore, angle DRK has to also be 78 degrees. Now let's move on to part C so that we can find KRH. KRH is this angle right here. And if we compare it to this angle that we're given, you'll notice that these two angles are same side interior angles. And same side interior angles are supplementary. That means that these two angles have to add up to 180. So we're going to take 180 and we're going to subtract 78 to find our answer. And we should get 102. Therefore, the measure of KRH is 102 degrees. Finally, we are going to find the measure of angle XHT. Angle XHT is this angle right here. And if we compare it to the other angle that we're given, you'll notice that these two are vertical angles. Vertical angles are always congruent. So if this angle is 78, then XHT must be 78 degrees as well. And that is it for question number 3. Moving on to question number 4. This question asks us to find the measure of FMT and to tell them what angle relationship these two have. So we're given some information in this question. They tell us that the measure of angle HVA is 112 degrees and that the measure of KAP is 68 degrees. Since we have this information given to us, we should label this information on our diagram. Angle HVA is this angle right here, and we know that it is 112 degrees. Angle KAP is this angle right here, and we know that it is 68 degrees. What we want to do now is find the measure of angle FMT, which is this angle up here in the upper right-hand corner. If we compare this angle to the angle that we know is 112 degrees, you'll notice that these two angles are alternate exterior angles. So that actually answers part B for us. The relationship that these two have is that they are alternate exterior. And since they are alternate exterior angles, that means that they are congruent. So if HVA is 112 degrees, then FMT must also be 112 degrees. And that is it for question number 4. Question number 5 is quite simple. all we're doing here is identifying the type of angle relationship each of these angles has using our transversal vocab. Looking at the first pair of angles, you'll notice that these two angles look exactly the same and they have the same orientation. Therefore, they must be corresponding angles. The next set of angles are on the opposite sides of the transversal, and they are inside the parallel lines, making them alternate interior angles. If we look closely at the next set of angles, these two angles are directly across from each other, making them vertical angles. Our fourth set of angles are two angles that are on the same side of the transversal and are inside the parallel lines, making them same side or consecutive interior angles. Then our final set of angles are two angles that are on opposite sides of the transversal and are outside of the parallel lines, making them alternate exterior angles. And that's it for question number 5. Moving on to question number 6. We have another transversal here. And in our question, they want us to find the measure of angle HNM and find the measure of angle CWR. But before we do that, we have to look at our question and look at the information that we're already given. They tell us that the measure of angle BKM is 143 degrees and that the measure of angle DLP is 26 degrees. As you know, first things first, we have to take this information and label our diagram with it. So let's find BKM on our diagram. And BKM is this angle right here, which we know is 143 degrees. DLP is this angle right here, which is 26 degrees. So we're going to start with part A, and we're going to find the measure of HNM. HNM on our diagram is going to be this angle. And if we look carefully, you'll notice that this angle and HNM are alternate interior angles. So we're going to write the words alternate interior angles. Alternate interior angles are always congruent. So if BKM is 143, then HNM also has to be 143 degrees. So we finished part A. Now let's move on to part B. For part B, we're finding the measure of CWR. And CWR is this angle in the upper left-hand corner. If we compare this to angle DLP, we'll notice that these are actually two alternate exterior angles. And once again, any two alternate exterior angles are going to be congruent as well. So if DLP is 26 degrees, then CWR also has to be 26 degrees. And that's it for question number 6. Now for question number 7, this one is actually just like all the other questions. You'll notice we're given a transversal, but this time we're using our transversal relationships to solve for a variable. In part A, we're going to determine the value of x, which means that we solve for x. And in part B, we're determining the value of y, which means that we're solving for y. So once again, we're going to look at the information that we're given, and we're going to label that information on our diagram. So we're given that the measure of C and L is 6x minus 8.4 degrees. FBH is 14y minus 24 degrees. And THR is 3x plus 27.3 degrees. First thing I'm going to do is find C and L on my diagram. And that angle is going to be right here in the upper right-hand corner. Angle FBH is going to be this angle right here, kind of towards the middle. And THR is going to be this angle towards the bottom left. Now, if you think about it this way, this is actually two different sets of parallel lines that share one transversal. The transversal in this case is line WC, and our sets of parallel lines are XD, TZ, YF, and LP. Basically, each of these transversals, if separated, have corresponding angles that match each other. If we think about this carefully, angle THR, if we were to move it to our other transversal, would end up right here. What that means is that angle CNL and angle THR would actually be a set of vertical angles. And we know that any two vertical angles are congruent. Congruent means that these two are equal to each other. So we're going to set up an equation that says 3x plus 27.3 is equal to 6x minus 8.4. Now that we have our equation set up, we're going to use algebra to solve for x. We would first start by subtracting 3x on both sides, and after that, we would add 8.4 to both sides. Then we would divide both sides by 3 to obtain the fact that x equals 11.9. Now that we know this, we can move on to part B. Now, for part B, we can compare any of these angles, but we're going to compare FBH to T. Actually, we're going to compare FBH to CNL. If we compared FBH to CNL, we'll notice that these are two same side exterior angles. And we know that same side exterior angles have to add up to 180 degrees because same side exterior angles are supplementary. So we're going to set up an equation that says our two angles add up to equal 180 degrees. This means 14y minus 24 plus 6x minus 8.4 equals 180. Now you may be thinking, we can't add an x and a y together. You'd be correct. However, we already know what x equals because we just solved for it in part A. So what we're going to do now is we're going to actually plug our x value or substitute it back into our equation. So we should end up having an equation that looks a little something like this. Now, after we have substituted our x value back in, we're going to combine like terms, subtract both sides by 39, and then divide by 14. This should leave us with the fact that y equals 10.1. And those are our final answers for question number 7. Now let's move on to the final question. For question number 8, we are completing the proof and we're using the word bank that we're given above. We are given the fact that line CD is parallel to GH and that angle DIJ is congruent to angle KJF. What we're trying to do here is prove that line GH is also parallel to line EF. So what we first have to do is look through all of the statements that were given in our word bank and see if we can fill in the blanks. Now, for number 2, if we're given that CD is parallel to GH and that angle DIJ is congruent to angle KJF, the only statement that makes sense here is that angle DIJ is congruent to angle BKH. Like I said, since we do not know yet that GH is parallel to EF, this is the only thing we can assume as of right now. Now, the reason that DIJ, this angle right here, is congruent to angle BKH right here is because these are two corresponding angles. So our reason is going to be that corresponding angles are congruent. And if you read carefully, there's a statement in our word bank that says, if two parallel lines are intersected by a transversal, then corresponding angles are congruent. Now that we have that filled in, we can move on to statement number 4. Once again, if you think about this logically, the only one that really makes sense here is the fact that angle BKH is congruent to angle KJF. Now, for this reason, we actually have to look through statements 2, 3, and 4 together. So if DIJ is congruent to BKH, and we know that angle DIJ is congruent to KJF, then we can assume that BKH is also congruent to KJF by the transitive property. So our reason for number 4 is going to be the transitive property. And finally, if you go back through each of these statements, the only logical reason for us to prove that GH is parallel to EF is the fact that if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So again, if we have corresponding angles, then our lines are parallel. And that is it. We have completed this proof using the word bank. And that's it for the 1.3 test review.